Hello mathematicians, in this video we are going to study the relationship between the roots and coefficients of a quadratic equation. So let's write down the standard form of the quadratic equation, which is ax square plus bx plus c equals to 0, where a is not equal to 0. And since a is not 0, we can divide the entire equation by a and we can get the final equation where the coefficient of x square is 1. The whole purpose of dividing the equation by a was to get the coefficient of x square as 1. And let us assume the roots of this equation are alpha and beta. If alpha and beta are roots of this equation, we can write this equation as x minus alpha into x minus beta is equals to 0. Okay, and multiplying these two, we get x square minus alpha x minus beta x plus alpha beta is equals to 0. And now taking x common, minus alpha plus beta into x plus alpha beta is equals to 0. And since alpha and beta were roots of this quadratic equation, we can generalize it as sum of roots into x plus product of roots is equals to 0. So this is our second equation and this was our first equation. Okay, so now in both the equations we have coefficient of x square as 1. Okay, and now let's compare these two equations now. Okay, so b by a is equals to minus sum of roots, or minus sum of roots is equals to b by a, and we can write sum of roots as minus b by a. Okay, also the product of roots should be equal to c by a. Okay, let's compare the constant term here. Here it was product of roots and here it was c by a. Product of roots is equals to c by a. Okay, and now note that given the roots of a quadratic equation, we can also write the quadratic equation. Okay, so and this is how the quadratic equation is written if alpha and beta are the two roots of that equation. Okay, so let's verify this relationship by using one of the examples. Let's say x square minus 3x plus 2 is equals to 0 is your quadratic equation. Now here the roots are let's use method of factorization. The product of first and the third coefficient is 2 plus 2 and the middle term is minus 3. We have to find two numbers such that the product is plus 2 and sum is minus 3. Let's say since the product is positive, both should be negative, then it is minus 1 and minus 2. Okay, so let's write down, split the middle term as x square minus 2x minus x plus 2 equals to 0. I have just split the middle term. Okay, so this is x into x minus 2, taking minus 1 common in these two terms, minus x minus 2 is equals to 0. Taking x minus 2 as common, we get x minus 2 into x minus 1 is equals to 0. So the roots of this equation are 1 and 2. Okay, now if this is alpha, this is beta, sum of roots alpha plus beta is 3. Okay, and alpha beta is 2, and this should equal to minus b by a. Let's calculate the value of minus b by a. B is minus 3, a is 1 and c is 2. Minus b by a is minus 3 into minus 1. Okay, this is 3. And c by a is 2 by 1. This is 2. Alright. So therefore, alpha plus beta is equals to minus b by a and alpha beta is c by a. Now let's take another important example. If alpha and beta are roots of quadratic equation which is given by x square minus 5x minus 7 is equals to 0, then find the equation whose roots are alpha square and beta square. Since we have established the relationship between the roots and the coefficients of a quadratic equation, we can solve this problem without even finding out the roots of the equation. Okay. So now for this first equation, we have alpha plus beta is minus b by a, which is minus 5 into minus 1 by 1. This is 5. Okay. And alpha beta is c by a, which is equals to minus 7 upon 1. This is minus 7. Okay. So now we have to find the equation whose roots are alpha square and beta square. Now from here, from the generic equation, we just discussed that if alpha and beta are roots of any equation, then the equation is given by x square minus sum of roots into x plus product of roots. Okay. So now if alpha, we have to find the equation whose roots are alpha square and beta square. So the equation should be x square minus alpha square plus beta square x plus alpha square beta square. This is your equation, but we do not know the values of alpha square plus beta square and alpha square beta square. And that we can derive using these two equations. Alpha plus beta is 5 and alpha beta is minus 7. Let's try to find out alpha square plus beta square. So let's use that identity whole square. Alpha plus beta whole square is alpha square plus beta square plus 2 alpha beta. Okay. So now we know the value of alpha plus beta, that is 5. 5 square is 25 is equals to alpha square plus beta square plus 2. And let's substitute the value of alpha beta, which is minus 7. 25 is equals to alpha square plus beta square minus 14. Okay. So alpha square plus beta square is 25 plus 14, which is 39. Okay. And alpha square beta square is alpha beta whole square. And what was alpha beta? It was minus 7. This is 49. And now we can write down the quadratic equation whose roots are alpha square beta square. So therefore it should be x square minus alpha square plus beta square into x plus alpha square beta square, for which we have already found out the values. This is x square minus 39x plus 49 is equals to 0. So in this example, we were given the roots of a quadratic equation, x square minus 5x minus 7 is equals to 0, and we had to find the quadratic equation. So whenever there is a problem which says that you have to find the quadratic equation given the roots, you have to use this generic equation, which is x square minus sum of roots into x plus product of roots. Okay. So now the approach here was, since we were given alpha and beta were roots of this equation, alpha plus beta was minus b by a, which was 5, and alpha beta is minus 7. And then to find out the quadratic equation with roots alpha square and beta square, we wrote as x square minus alpha square plus beta square into x plus alpha square beta square is equals to 0. And we could find both of them using some calculations which is already there in the video.